Okay, so I want to walk through this 2017 simply supported beam question. At the start, it looks quite difficult, but if you draw a free body diagram and you read the question carefully, it's not that bad of a question. Okay, so the first thing I want to do is I want to draw a free body diagram of this beam. Now I have a uniformly distributed load. Remember, that's what UDL stands for. And I want to get rid of, and it's acting between A and B. So how I get rid of this uniformly distributed load, I have newtons per meter. I want to get newtons. You multiply the UDL by the distance it's acting across. So UDL times distance acting across. And the reason I say that is in some beams it will act the entire length of the beam. Here it's only acting between A and B. So I want to resolve that UDL into a point load. So it's 40 newtons per meter times, it's acting across 1 meter, cancel, so it's 40 newtons. Where does it act? Well, when I redraw the beam, I need to remember that it acts at center of 1 meter. So when we reposition these, we always put it at half of where it was acting. So it's at the center of that 1 meter, which will be half meter or 0.5 meters. Okay, so I'm going to redraw my beam now. Excuse me. I'm going to redraw this beam and reevaluate and see what it is I'm being asked to do. Okay, so there's my beam. Add in a bit of color. Not actually, I won't. I don't need it. Make for a better UDL. Okay, so I've got force reaction A, and I've got another reaction force B. I know this UDL is acting at 40 newtons, and I have L acting here too. Now, the question tells us a simply supported beam of length 1.25 meters is designed to support a UDL with the ability to support a further point load L at the overhang. The support reaction at B is given as 26 newtons. So if you don't read the question, you might have missed that, but we were told that this force is 26 newtons. Okay. And now if I just add in my distances, so looking at the one I had above, from A to there, 0.5, to there, another 0.5, and here is another 0.25. So at the start, I had a beam length 1.25. Here, I have 1.25 meters. And that's also a quick little check you can do to make sure you haven't drawn anything wrong. Okay. Excuse me. So, now we follow a process. So if this thing is going to be in static equilibrium, sum of the forces should equal 0, or the forces going up need to equal my forces coming down. So that's just an easier way of thinking about it. So what does that mean? Well, that means that A, it's going up, plus 26 newtons, needs to equal 40 plus L. Okay. The other thing that needs to happen if this beam is going to be in equilibrium is that the sum of the moments needs to equal 0 at every point. Okay. So what I'm going to do is I'm going to take moments at this point here, because that's going to eliminate A out of the equation and leave me with a variable L that I can solve for. So let's go and try that. I'll keep the pen as blue. So the sum of the moments about this point, and remember, a moment is equal to a force times a perpendicular distance. So here we've all got we've all got vertical forces, which means we need the horizontal distance to the point it's been turned about. So it's been turned about A. So that 20, if I'm looking at some of my moments here, is 20 times, how far away is it from A? It's 0.5 meters away. So 20 times 0.5. The reason it's positive is because it's going to twist me clockwise. Okay, the other one that's going to twist me clockwise is this L. So plus L times 1.25. And now there's a minus moment. And the reason this is a negative moment is if I'm pinned here, and I'm only evaluating this force to 26 newtons, if I press it, it will spin you counterclockwise or anti-clockwise. So some of the moments clockwise we're taking as positive, moments counterclockwise we take them as negative. And we've covered that in class. So minus, and we have 26 newtons. How far away is the 26 from A? It's 0.5 plus 0.5, so 1. And sorry, I've just spotted this 20 here. That should have been a 40 because this is 40. That's just my bad handwriting. That I almost cut myself out. Okay, so I can tidy that up. 40 times a half will give me 20. Plus 1.25 L minus 26. And because these should be in equilibrium, the sum of these forces should equal 0. Equals 0. And if I tie this up, 20 minus 26 gives you minus 6. I can bring it over and I'll get 6, so equals 1.25 L equals 6. L is equal to 6 over 1.25, which gives me 4.8 newtons. Okay, so now I know L, I can come back to this first statement here and solve for A. So A plus 26 newtons is equal to 40 plus 4.8. So A is equal to 44.8 minus, so when I bring this 26 over the equal sign, it becomes negative, and I'm just tidying up that 40 plus 4.8. So 40 plus 4.8 gives me 44.8. Bring the 26 over, it becomes negative. And A is equal to 18.8 newtons. Okay, and that's the question solved.